Everyone, today we are going to discuss about anti-arrhythmic drugs. Before going to the mechanism and what is anti-arrhythmic drugs, let's have a look on basics of heart. Here it is a simple diagram of a heart showing the four chambers and sino-arterial node, arterioventricular node, and bundle of base and Purkinje fibers. As we all know that the heart beats when an electrical impulse from the natural pacemaker, that is sino-arterial node, moves through it. There is an electrical impulse that moves from sinoatrial node to the atrioventricular node. The normal sequence begins in the right atrium. This one is the right atrium, spreads throughout the atria and to the AV node. From the AV node, the impulse travels down a group of specialized fibers known as Purkinje fibers to all parts of the ventricles. These are the auricles and these are the ventricles. Now, as long as the electrical impulse is transmitted normally, the heart pumps and beats at normal rate. This is the thing, that as long as the electrical impulse is transmitted normally, this is the normal sequence of transmission of the electrical impulse. Thus, whenever unless and until the electrical impulse is transmitted normally, the heart pumps and beats at normal rate. This is about the basic of heart, basic impulse transmission of impulse transmission in a heart. Now the thing is that uh, let's come to the topic. What we have, it is arrhythmia. Or now, what is arrhythmia? Cardiac arrhythmia may be defined as abnormalities at the site of origin of impulse or disturbance in the rate and conduction of the impulse. Let's see what was happening here is that uh, there was a site from where the impulse is generated, and this impulse is transmitted throughout the throughout its conduction system throughout the different regions of the heart. Now, this is the thing. Cardiac arrhythmia may be defined as abnormalities at the site of origin of impulse or disturbance in the rate and conduction of the impulse. To understand the rhythm of heart, we have to look over the electrophysiology of heart. What do you mean by electrophysiology? Is that in electrophysiology there is the measurement of the membrane potential of the conducting system in the heart with systole or diastole or resting state. To understand electrophysiology, uh, let's have a look on some basic terms that will come when we study anti-arrhythmic drugs. The first one is that impulse generation. The first step of electrophysiology includes impulse generation. The second step includes conduction, that is the impulse is transmitted. The third one is excitability, and the fourth one is refractory period. What is conduction? In respect to this is that the rate of conduction may be defined as the rate of rise of action potential. What is the rate of rise of action potential? A more completely polarized membrane depolarizes faster because more sodium channels have recovered. Now you have studied about repolarization and depolarization in your previous classes, but for basics, I would like to define you once again. What is depolarization? It is during the process of depolarization, there is shifting from a negative to a positive membrane potential occurs. That means normally the membrane potential of the cell is in negative, and what happens during depolarization? The negative value changes to a more positive value. This happens when depolarization occurs. It typically occurs due to influx of cations or efflux of any kind of anions take place within the cell. What happens is that in a cell, when there is excess cations are in the cell, then the inner potential will be positive, but when there is excess anions in the cell, it will be negative. What happens during depolarization is that the cations are transmitted into the cell while the anions are transmitted out of the cell. This causes the negative value of the action potential changes to from negative to a more positive value. It is also referred as hyperpolarization. That means depolarization is also known as hyperpolarization. Now, repolarization or hyperpolarization is opposite to it. As we all know that the shifting from a more negative value to a more positive value is known as depolarization. In the same way, the shifting from a more positive value to a more negative value is known as repolarization, and repolarization is also known as hyperpolarization. When we study further after conduction, the next one is excitability. What is excitability? It means it is the strength of an stimulus required to produce action potential. uh, Stimulus, you are well aware about the stimulus. The strength of an stimulus which is required to produce an action potential is known as excitability. When resting membrane potential decreases, when there is decrease in resting membrane potential, there is decrease in the gap between resting membrane potential and threshold potential, and this causes increase in excitability. Now, what is RMP, that is resting membrane potential, and threshold potential? I have discussed about this. What is resting membrane potential? It is resting membrane potential is the voltage difference across the cell membrane when the cell is at rest. Uh, this is the voltage difference when the cell is at rest. Now, what is threshold potential? It is the critical level to which membrane potential must be depolarized to initiate an action potential. Critical, that means the potential beyond that the action potential is generated or initiated. uh, with the diagrams you will get it clear what is threshold and RMP. Now, but before that, there's a next one, that is a refractory period. Refractory period is also known as non-responding period, and it is the period of interval in between two action potentials. The period of interval in between two action potentials is known as refractory period, or the period of interval in between two propagating action potential. Thus, it is also known as non-responding period. Uh, I have just discussed about this. Um, the next one is that, yeah, no. As we all know that you can see it here, electrophysiology includes four steps. The first one is impulse generation, conduction, I have just mentioned here. The next one is excitability, and thereafter refractory period. Now, we have to understand impulse generation in brief. There's here you can get